Hello, this is Sheila Devi. I am the instructor for your course on artificial intelligence. So this is the first lecture in this course, and I will just do a small introduction before I start the course. So this will talk about some introductory concepts of this course. So basically, the textbooks which need to be followed are as follows. The first textbook is Artificial Intelligence book by Russell and Norvig, which is the one which has been mostly followed in this course. Another book is the Artificial Intelligence book by Luger, which is used for some small specific topics here and there. And there are some other textbooks also which have been followed, and I will let you know from time to time what are the textbooks that I have used over there. So what are the broad topics which we will be covering in this course? So basically we'll start off with talking about what are agents and what are intelligent agents and the different types of intelligence agents that we have. So we have something called a simple reflex agent, and we also have more complex agents, okay, which are more powerful. So we'll talk about different types of agents. And an important topic in artificial intelligence is the general problem solving. In other words, if you have a problem, how do you have a general procedure for solving the problem? So usually you use like a search algorithm. So you search for a solution to the problem. So this is something like the way human beings do the problem solving. And the next topic will be on logic. So what are the different types of logic we have? Mainly you have things like propositional logic, etc. And when we represent things in logic, then how do we carry out reasoning using that logic? Because obviously when we are talking artificial intelligence, when you have certain knowledge, you are trying to find new knowledge by using the means of reasoning. And also you have things like theorem proving, which will tell you whether something is right or wrong, etc. And then we also have other types of logic like fuzzy logic, non-monotonic logic, etc. So we will talk about all those types of logic. Another topic is planning. So how do you find a plan to carry out a certain goal? For example, if you have some space mission, so what are the steps which need to be taken in the space mission? So you plan it out. So that is what we mean by planning. So there are different types of planning algorithms. So we'll go through those different planning algorithms. And as we know, learning is a very important concept over here. So we have things like supervised learning, unsupervised learning, reinforcement learning, and in each of these, for example, supervised learning, you have things like different machine learning algorithms, deep learning algorithms. So we'll be going through all those type of things. And when we come to languages, of course, along with the usual languages which are there, we also have some AI languages which are used. So these AI languages are things like Lisp, Prolog, etc., where some concepts, for example, list processing and processing of text, etc., is carried out, and Prolog, which you could call as something like a shell, expert system shell. So we'll be going through some of these languages. And communication, of course, the agent needs to communicate with the human being or communicate with each other. So how this communication is carried out. So that is what we mean by natural language processing. And we'll talk about other things like multiple agents, web agents, negotiating agents, and all these different types of agents. Okay, so basically what are we doing in artificial intelligence? We are trying to model how the human being carries out a task. In other words, you are trying to model human cognition or the mental faculty which the human being carries on and then comes to a decision and carries out that decision. So you are trying to make the computer do things which the human being does now, and it is considered to be something intelligent. Okay, so you want the computer to do things which require intelligence basically. So that's the basic idea over here. Okay, so let us go into some definition of artificial intelligence. So we can say that it's a branch of computer science. Okay, so AI is considered to be a branch of computer science where you are trying to study and create computer systems that exhibit some intelligence, okay, or which we associate with intelligence in human behavior. So if when a human behavior does even things like recognizing a person or even a child recognizing a person, you can say that it is using its intelligence, right? So that intelligence we are trying to model by using a computer basically. Okay. So in other words, you are trying to find a machine which thinks. Okay. So we want to classify a machine as thinking, or in other words, if it needs intelligence to do something, then we say it's a thinking machine, right? So we are trying to create that in artificial intelligence. So here are some different definitions given in different places. So behavior of a machine, if when performed by a human being, would be considered intelligent. Another is study of how to make computers do things which at the moment people are better. So what people do better now, okay, how do you make a computer do the same thing? Another one is theory of how the human mind works, okay. So you try to see how the human mind works and you try to simulate that to get the same result. So these are different definitions of artificial intelligence basically. Here are some more definitions from different places. So the famous Alan Turing, so you have the Turing test which we will talk about little later. So actions that are indistinguishable from a human's. Okay, so if the machine carries out a task which looks like it's been carried out by a human being. So AI is the study of complex information processing problems that often have their roots in some aspect of biological information processing. The goal is to identify solvable and interesting information processing problems and solve them. So this is David Marr from MIT. The intelligent connection of perception to action. In other words, the computer perceives something and then after perceiving something it needs to take an action. So that action which it takes, how it comes to decide what action to take, that is where there is a intelligence which is involved. So when we are talking about artificial intelligence, these things are some of the things which need to be done. Learning new concepts and tasks, okay, reason and draw useful conclusions about the world, remember complicated interrelated facts and draw conclusions from them. So that is something like the expert systems which we talk about. Understand a natural language or perceive and comprehend a visual scene. Look through the camera and see what is there, okay, and move around. So that is something like what happens in robotics basically, okay. Plan sequence of action. So that is what we call planning. How do you plan? For example, you want to go and buy some milk and oranges and bananas, say, right? So what is the series of actions that you're going to carry on? So you'll have to have something like leave the house, go to the supermarket, buy some milk, go to the hardware store, buy something, etc., right? And then come back home. So what you have is a series of actions to carry out a task, okay? Next is offer advice based on rules and situations. So that is like the expert system. So you may have an expert system which will, if you give the symptoms of a person, it tells you what disease they have, okay? So that's what we mean by offering advice. And of course, it may not necessarily imitate human thought processes. In some cases, It could be done in a different way but get the same result basically. Okay. Perform tasks that require high level of intelligence, etc. So that's what you're trying to see how to make the computer do basically. So here is an overall block diagram of artificial intelligence. So if you see in the middle, it tells you all the subjects that are covered under artificial intelligence. So we spoke about reasoning, learning, planning, right? Um, Knowledge acquisition and all those other things, right? And of course, there's a lot of uncertainty involved in that. And then we have some parent disciplines. So the parent disciplines are the disciplines from where artificial intelligence has actually come up. Okay, for example, philosophy, psychology, maths, physics, computer science, etc. And if you look down, you can see some application areas of AI. For example, game playing. So game playing is a very important application area. So things like chess, checkers, all these types of games, theorem proving, okay, language understanding, robotics, etc. So these are some application areas which we are talking about. Okay, so here we can see the different topics which will be covered under AI basically. Okay, so what are these topics? You have things like knowledge representation. So how do you represent knowledge? Okay, so that's a very important concept. So when we talk about say ordinary data structures, algorithms, etc., we talk about data. Okay, so you have data to solve a problem, whereas here you talk about knowledge. For example, you can have knowledge in your database like all crows are black. Okay, so that would be like a knowledge. So you need to do representation of knowledge. Okay, not only facts. Okay, so you need to have facts and rules, etc. Theorem proving, game playing, common sense reasoning. Okay, learning models, inference techniques, pattern recognition. Okay, so some classification algorithms, searching and matching, etc. And logic. So you have things like fuzzy logic, temporal logic, modal logic, all these things, planning. And other sub areas are like natural language understanding, computer vision, understanding spoken utterances, okay, intelligent tutoring systems, etc. Okay, so these are all some sub areas which will be basically covered. So if we come to intelligence, obviously when we say that artificial intelligence is when the computer does something intelligent, we need to be able to define what is intelligence. Okay, so let us now take up the definition of intelligence. So when we come to intelligence, if you look at the dictionary, this is what the dictionary says about intelligence: the ability to learn and understand or to deal with new or trying situations. Okay, so if you have a new situation, how do you deal with that? Okay, so that is where you need intelligence. And how do you reason? The skilled use of reason. Another one is the ability to apply knowledge to manipulate the environment, okay, or to think abstractedly as measured by objective criteria. The capacity to learn and solve problems, the ability to act rationally. So these are all the definition which is given in the dictionary. Okay, so basically it's the capacity to learn and solve problems. Okay, so the ability to solve novel problems. Okay, if you are given a new problem for which you don't have any solution, the ability to do that, and the ability to act in a rational manner. So rational manner means in a manner which is gives the right decision basically. Okay, the ability to act like the way human beings act. Okay, so this is what you mean by intelligence, and artificial intelligence is to build and understand intelligent entities or agents. Okay, and there are two main approaches, like you say, engineering versus cognitive modeling. So basically there are things like the engineering part of it, for example the robotics, etc., and then we have the cognitive modeling, okay, so which we do by programs, etc. So we will not be going into the robotics part over here basically. We are seeing it from the computer science point of view. Okay, so what is it that you require, okay, in the case of learning or intelligence, right? So if you want to act in an intelligent way, what are the different characteristics that should be there in your AI system? It should be able to interact with the real world. So how do you do that? Maybe you can have some sensors. So if you take human beings, we have sensors like eyes, nose, touch, right, mouth, whatever, all these things. So in the case of the computer also, you need to have sensors so that it's able to interact with the real world and find out what is happening in the real world. So what you need to do is to perceive, to understand and to act, okay. So, so here ability to take action, okay. So you need to understand what is happening in the real world and you need to take action for that. Reasoning and planning. So you are modeling the external world given some input. Solving new problems, ability to deal with unexpected problems, etc. Then learning and adaptation. We need to continuously learn and adapt. Okay, so as the real world changes, we need to also adapt ourselves according to what is happening in the real world. Our models have to be always updated. Okay, so that is these are the things which are necessary for basic intelligence. Okay. So these are some people who have really been pioneers when it came to artificial intelligence. So you find many of them were working in the 40s, 50s and 60s, okay, 1940s, 50s and 60s. So the first is McCarthy. So the first thing he is known for is Lisp, okay. So Lisp is a list processing language and it was started in around 1960. So he came up with it around 1960 and it carries out some type of logical programming and non-monotonic. He is also known for non-monotonic reasoning and all these things. Next one is Minsky. So he was the founder of AI lab at MIT and there's a knowledge structure called frames. So he is responsible for that particular knowledge structure. Then you have Simon. So Simon is known for general problem solver. So that's a very important software he came up for solving general problems. And of course he has worked on social networks and come up with the power law, which is another important thing. Then you have Arthur Samuel. So Arthur Samuel coined the term machine learning and he was known for using AI for game playing. So in other words, he was responsible for all the checker programs which were written in the 1950s. So he wrote a series of checkers programs basically. Then you have Alan Newell who came up with what is called the logic theorist, which is logic based reasoning, general problem solver, okay, and he was responsible for what is called the chess machine. Then you have Nielsen. So you have the A-star algorithm. So the A-star algorithm is a very important heuristic search algorithm which we will be talking about later. So he is the one who came up with that algorithm and he also talked about planning and there's a book written by him on artificial intelligence, okay, which is also a very well known book. So we'll now talk about what is called the Turing test. So what is a Turing test? So Turing test, also called the imitation game. In other words, you have a human interrogator who is separated from the AI system, okay, or the computer system, okay, and there's a teletype with which he communicates with the AI system. And if the interrogator cannot tell whether it is a computer or it is a human being, okay, at the other end, the computer actually passes the test. So that is what is known as the Turing test. Okay. Now, what are the capabilities that the AI system needs to have to pass the Turing test? That's what we have to see. So the one is that it should be able to work with natural language processing. So it should be able to communicate with the interrogator. So the interrogator asks some questions, so it should be able to understand that, and it should be able to reply to those questions in natural language processing. Next is the knowledge representation. So whatever information it has, it should be able to store it, okay, so that it has all those information when it needs to answer questions, okay, or communicate with the interrogator. Third one is what is called the automated reasoning. So when the interrogator asks a question, it should be able to reason out using the information or the knowledge it has stored, okay, and it should be able to draw conclusions, answer questions, etc. And the fourth one is machine learning, where it needs to adapt to new circumstances. So these are some of the capabilities required by a computer if it needs to pass what is called the Turing test. Okay, so let us see, it's a multidisciplinary subject, AI. Okay, so number of different areas are involved here. First one is of course the computer engineering. Okay, so obviously the artifact we are using is the computer, right? So the computer is an important aspect over here. So computer science, data science, that is storing of the information in the data, machine learning, deep learning, all these things come under the computer science. And then you have subjects like philosophy, psychology, cognitive science. Okay, so these are another important set of subjects. Okay, another is mathematics, physics, etc. So mathematics, of course, things like logic, what we are using, logic, reasoning, all these things will come under mathematics. And of course, things like linguistics, when you do natural language processing, robotics, where you have the machine, moving from one place to another, carrying out tasks, etc. So that is robotics. So all these areas will come under AI. Okay, so all these are something like the parent disciplines of AI. Okay, so let us see how these different topics are used over here. First of all, philosophy, if you consider, logic of course also comes under philosophy. You had Aristotle working on some type of logic in the earlier parts, okay. Methods of reasoning and looking at mind as a physical system, foundations of learning, language rationality, all these things come under philosophy. And then if you look at mathematics, you have formal representation and proofs, algorithms, okay. So here what happens is you have algorithms which are intractable basically, okay, because you are talking about really big data, etc. So how do you work on these intractable problems? Then you have things like decidability, computation, all these things. Then probability and statistics. Obviously, you have a lot of uncertainty involved. So how do you model this uncertainty? One way is by using probability, or one of the important ways is by using probability. Okay, so these, that's another area. Then economics. So in economics, obviously when you make a decision, okay, so how do you take a decision? Okay, so to taking a decision is based on decision theory, and when there is more than one method of doing it, you can use what is called the utility theory. So what is the method which gives the highest utility among the among the different actions that you can take, okay. And then you have rational economic agents, etc. Neuroscience, right? Neuroscience, neurons as information processing units. So we know that if we look at the way the brain works, okay, so it's like a neural network basically. So there are neurons which are highly interconnected with each other, etc. So neuroscience is a very important concept there. Psychology, cognitive science. Okay, how do people behave, perceive, process cognitive information, represent knowledge, etc. Right? So when we take in things, okay, how much can we store in our brain, right? So how do we carry out the knowledge representation? How do we do the abstraction? Okay. So we can see that some information is stored in the brain, some information is forgotten, you know, all those type of things. So that cognitive science and psychology is very important to, if we you know, study that, it will help us in AI also. Computer engineering, so building faster computers, we know that as the days go by there have been faster and faster computers. So AI started in the 1950s, and since then there's been so much improvement. Okay, the computers are becoming faster and faster, and the storage is gone up like anything, right? So all these things actually help you in AI, and you're able to get better and better programs and more accurate programs because of this. Then control theory. So when you have an objective function which you need to maximize, you use the control theory, feedback systems, etc. And linguistic, how do you represent knowledge, how do you work with natural language, all these things. Okay, so all these are something like the parent disciplines, making it a interdisciplinary area basically. So the foundation of AI is based on mathematics, neuroscience, control theory, linguistics, etc. Okay, so mathematics is very important because if you see, it's only after say 1990 or so that AI picked up in all these things. Okay, we had things like decision theory, utility theory, mathematics. In speech recognition, you have Markov processes which came up, etc. So you find that it became a very sort of going more and more towards you know, a full mathematical model of the AI systems. So in mathematics, okay, logical methods are used. Okay, so when you use logical methods, obviously you have Boolean logic where you have everything represented by zeros and ones, and then you have fuzzy logic where in fuzzy logic it can belong to, it can be a member of it can be a member, you know, membership with a membership value basically. And then uncertainty, obviously most of the systems which we are working on is based on uncertainty. So when you have uncertainty, you need to be able to handle that uncertainty, okay? And this is done by using probability theory, other types of logics like modal, temporal logics, etc. You have non-monotonic logic. So all these things actually help you to deal with the uncertainty. So neuroscience, how the brain works. Okay, how close are we to have a mechanical brain? More recent studies use accurate sensors to correlate brain activity to human thought. Earlier studies used injured and abnormal people to understand which parts of the brain work and which don't, etc. Okay, so neuroscience also goes into artificial intelligence. Then control theory. So what you're basically trying to do is, you in control theory, the feedback that is used, right? So you're trying to use that, okay, and see how it can be used in AI basically. So linguistic speech, speech is a big part in human intelligence. It's only through speech that we understand things, and we use these, you know, what we understand it goes into our brain, okay, to form human intelligence. So speech is a very important aspect. So the language is important there. For example, you can see that children, they would have, as they grow older, you find that they are able to create sentences which they have never heard of before, right? So language is actually very important, and we actually, if you see, we think in a particular language. For example, I may think in English, right? So the thinking and language is actually sort of very closely connected to each other. Okay, so now what we are going to talk about is something like the history of AI. Okay, so we'll stop here, okay, and take a break and continue this in the next session. Thank you.